So alkaline phosphatase is another important component in the restriction digestion process. So this is not a part or a component of the restriction enzyme process, which is we've seen the methylases is a part of the restriction enzyme process, but the alkaline phosphatase is important for the restriction digestion, overall restriction digestion of the vector as well as the DNA, mainly the vector. So as you have seen that in the previous slides, that the digestions of the restriction enzymes can generate the sticky ends that have an unprotected phosphate group. When this digested product have been used for ligation process with insert DNA, due to this presence of this unprotected phosphate group, they tend to religate by themselves and not ligating with the insert DNA. And for this reason, it is very important to treat the digested vector, especially the vector, which actually have the unprotected phosphate group, treated with phosphatases to prevent this religation. So the phosphatase, what they did, they dephosphorylate these 5' sticky ends unprotected phosphate, so they cannot, the vector cannot religate by themselves. They actually then ligate with the insert DNA. So apart from restriction digestions, which is used to prepare the vector and DNA, the insert DNA and vector can also be prepared by using a PCR. So PCR is a polymerase chain reaction, which makes 100 of copies of the same DNA sequences. The basic steps of PCR, which we will definitely discuss later. But first is just the denature the double-stranded DNA to break the hydrogen bonds between the nucleotides and generate a single-stranded DNA sequence. Then annealing a specific primer. So primer is an oligonucleotide which can be designed and get an order to the commercial vendors to get the primer. And this primer bind specific sequences of a single-stranded DNA. And finally, this single-stranded DNA has been extended with those primers to a double-stranded DNA. So in this way, it can make hundreds and thousands of copies of the same DNA sequences or DNA molecule, which we start at the beginning. In case of PCR-generated DNA fragment for cloning, DNA can be extracted from the tissues or any organisms like a bacteria, genomic DNA from bacteria, or a fungi, or a yeast, or any mammalian cell line. And then the insert, which we need to be ligated to the vector, has been amplified by using a specific primer. As we have said, that the primer can be designed there are a lot of various tools or applications has been there in the internet, so that we can use that one and we can generate the primer. But in case of preparing the primers, we need to be get few of the things. Number one is, do we want to put any restriction sites into the primer, or do we want any sequences that is actually overlapping with the vector sequence? So when we decide which way we should go, like for when we design the primer, which has an overlapping sequence with the vector, then we can do an overlapping PCR or a fusion PCR that has an overlap between the vector and the insert DNA, like maybe 20 to 30 base pairs. And in this PCR, we can actually join those vector and the insert DNA. And on the other hand, if we put a restriction sequence for a specific enzyme, then after the PCR, we extract the purified PCR DNA, and then we treat it with that specific restriction enzymes to the insert DNA as well as the vector, and then ligate the both to make it a one. So I'd like to request you again to check all the videos and also encourage you to come to the discussion class if you have any questions or queries. Thank you.